All right, so we remember that area is length times width because if you remember we had that postcard problem and we figured out that the postcard could be, and I don't remember how many it was, but it could be covered by a number of different squares. And we saw that if we had 2 squares on this side and 3 squares on this side, and we counted up, we saw that it was 6. But we could also see that if we multiplied the 2 by the 3, we got 6 total squares. So we know that length times width is going to be area of any shape that is square or rectangle. So we got that. Okay, so if that's what you and Finn did over on this table, tell me exactly what you guys did to figure out the area of our classroom. Now, keeping in mind, this is approximate because we kind of just did an approximate measurement of the length and the width 2 days ago.
When we copied down the approximate measure, we times the 13 by 7. Yeah, 13.50 and 7.50. The length by the width. And we got 192. So our approximate answer would be that.
Okay, so stop there for a moment.
192 square feet.
Okay.
Like, it's an approximate.
Okay, so we got approximately. We know it's approximate because our measurements are kind of approximate. Now, I'm just going to stop you there for 1 second. You guys said that you got 19.
No, yeah, 19. No, 192.
All right, so 192 what?
Square feet.
Square feet? Were we measuring in feet?
We also got square meters. Square meters. Yeah. It was 94.5 square meters.
And then we also just did 192.
Okay, now again, I'm going to stop you guys right there. Is there anybody else who calculated 13.5 meters by 7.5 meters? Is there anybody else that did that? Let's just check their math. Zach, did you get the same answer?
No, I got 101.25. Yeah, that's what it is.
Okay, 101.25. You know what, guys? I'm pretty sure that makes sense because right off the bat, I see here a 5 and a 5. And if I'm multiplying a 0.5 by 0.5, a half of a half is going to be 0.25, which is 1/4. So I'm leaning towards, and I already know if I was to estimate this, and I would say, 13, this is pretty close to 13 times 8. And I know that 10 times 8 is 80. And I know that 3 times 8 is 24. And I add those two numbers, that's about 104. So I know by estimating that probably 101.25 meters is more likely. Plus, there was more people who got that calculation.
Yep.
And nobody got 192. So I'm going to go with this calculation because that seems more reasonable to believe based on my estimating. So
I just did it rotating.
now, is that, here's a really important question. And I need everybody to listen to this. Is that the final step?
No.
Okay, now we're back. Now I asked, is this the final step? This table over here, is it the final step? You guys look like you're not sure. Okay, you're not sure. This table here, Jalasia, what do you think?
No.
Jalasia, why do you say no?
This is like all rectangle, but this part and where the doors and where it says color, that's not really a square. It's like going upward.
So you're talking about this little triangle here where the door is?
Well, there.
Okay, and what she's pointing to, ladies and gentlemen, she's pointing to the places in the room that we've already identified where some of the floor area is covered up. So,
It's hard to estimate those.
okay, so Jalasia says it's hard to estimate those.
We said you'd have to do an exact measurement, but it would be hard.
Okay, so what we do know then is that we do need to minus the areas covered, right? So I'm just gonna write this down because if this was my math problem and I was doing this on like on an assessment that was being handed in, I would want my teacher or whoever is marking it to know that I still have to minus the areas here that are covered up by the other items.
I pretended like that.
Okay, now gentlemen, I want to hear this answer over here, and Sophia, I want to hear yours in a minute. So just hold on. Yes.
I pretended that like the doors and stuff were all square,
Okay.
and then I kind of estimate them.
So what did you estimate them as?
If you go up, maybe it could be like 5 inches or something across. But then you could add it or see.
Okay, and I probably wouldn't want to use inches. Why would I not want to use inches right now?
Because it's like America, they use in America, we use centimeters and
Okay.
Not in the U.S. and 2, just room's too big for inches.
Okay. Well, those are both good answers. One said here we're not American, and the other one said that in Canada.
We're not American and the room's too big.
Okay. Now, one common misunderstanding here is that still when we do a lot of building in Canada, we still use, like when I used to frame houses, I used to build houses when I was in university, and I still do a lot of construction and build sun decks and stuff like that. And we still use feet and inches. But another reason here is we've measured this in meters, so we want to stay consistent. Now, what we could do is we could say, you know what? This here is maybe about 2 square meters. This here is maybe about 1 square meter. Maybe this over here is about 2 square meters plus another 2 square meters. And maybe this little triangle here that cut off, maybe this is about 1 square meter. And I might add these up. Okay, but what I'm just trying to show you is that I can take a little bit of an estimate. And I've got 1, 2, 3, 4, 5, 6. So there's maybe about 8 square meters of area in our classroom that are covered up. So I'm going to take my 101.25. I'm going to minus my 8. And what am I going to get? Somebody calculate that for me.
What?
My 101.25 square meters minus my 8. Pardon me?
93.25.
All right, so I'm going to get my 93.25 meters squared. Now, last thing here, really quick. Gentlemen, last thing here, really quick. What would I probably want to tell the person who's assessing this? I would probably want to tell them that this is the approximate area. Because we didn't do exact calculations, we're just trying to get the approximate area based on what we could find out.